couple of seconds to jump in. And feel free to introduce yourself, those that you are joining us. I'm Christina. I'm a program manager at the Raspberry Pi Foundation. Super excited to have you. We'd love to hear where you're joining us from. I know a lot of folks are in Georgia, but feel free, type your name in the chat and your role.
And I'm Matt Richardson. I'm Executive Director of Raspberry Pi Foundation North America. I'm actually in Cleveland, Ohio right now. So we share a time zone at least. And if you're introducing yourself in the chat, make sure the session is selected at the top. It's not under event, it's under session. And,
yes. Awesome. Great. Hi, Yvonne.
Welcome.
Oh, cool. Yes. Hi, Mark, Brian. Thanks for joining us. All right. Well, let's jump in. Matt, I think I'm hearing a little bit of your caller on your microphone.
Yeah, I'll just hold it out here and then mute myself otherwise. Okay, thanks for letting me know.
And we know that, we've been doing this for a while. All right, well, let's get started, folks. Thank you all so much. Hi, Megan. Oh, Wisconsin. All right, so we do have some folks from outside of Georgia. I'm actually in Nebraska. I recently moved here. So if you're in Nebraska, let me know. Love to connect with some other computer science folks. All right. So as we mentioned, I'm Christina, this is Matt, and we are with the Raspberry Pi Foundation. We are here with the beginner coding session. Okay, so this is the beginner coding session with the Raspberry Pi Foundation team. I'm going to adjust a couple of windows so we have everything we need. All right. Okay. So Matt and I are part of a small team of 4 folks who represent Raspberry Pi Foundation North America. We are small, but we are mighty. And we do a lot of really great work for the larger Raspberry Pi Foundation, which is a UK-based charity, specifically based out of Cambridge, England. So I'm curious if anyone knows, feel free to put in the chat if you know about the Raspberry Pi Foundation. The mission of the foundation is to put the power of computing and digital making into the hands of people all over the world. So that looks like one thing, an affordable tool, which is the Raspberry Pi computer. I have mine. Where is it? Mine's down here. I think Matt probably has one too. So you may have heard about the Raspberry Pi. Oh yeah, Matt's got the
brand new one, Raspberry Pi 400. In the keyboard.
Nice.
I'm just showing off here, flexing.
Oh my gosh, and I see Yvonne. I hope I'm pronouncing your name. Yvonne, please correct me if I'm not. You've hosted 2 Raspberry Pi, like Raspberry Jams. That's amazing. I should have worn my Raspberry Jam shirt. That's awesome. That's so great. And seeing some other folks joining as well. Thanks so much for joining. But yeah, so this mission, it's a big one, and it looks like a bunch of different things. One is creating an affordable tool, so the Raspberry Pi computer. We also have programs such as AstroPi, which is our program where we have 2 Raspberry Pis up on the International Space Station. It's a program for young people to create code that runs on the International Space Station. We also have Picademy. Shout out to Yolanda, a member of the Constellations team. She is one of our Raspberry Pi certified educators. We also have youth programs such as Code Club and Coder Dojo. So a lot of awesome stuff that we do to meet this mission. So with that for today, I just wanted to do that quick introduction, and we're going to jump into our coding activity. We're going to be doing an introduction to Scratch and specifically doing a project called Stress Ball. We'll be taking questions throughout. That's why Matt is here. If any of you have ever done like a presentation, especially these virtual presentations, there's so much going on the screen. So I asked Matt to be here to help out. So he'll be monitoring the chat. He'll make sure that we get links in there for y'all. He'll take questions, make sure that I'm seeing those questions and answering them as we go along. And then we'll talk about some next steps and resources. So I'm ready to start coding. How are y'all feeling? I'm feeling good. So we are going to pull up. So we're going to be doing a coding activity with Scratch, which is a beginner-friendly block-based coding language. And as you may have seen, we have 2 sessions today. We have a beginner activity, and then we have like a more intermediate level activity. I wanted to do this beginner activity because I know for folks, they may be brand new to coding. And like, I think it was Brian who said in the welcome session, like, digital literacy now is more important than ever. And I want to make sure that if you're new, we welcome you. We want you to try out this beginner activity. We want you to learn about Scratch and the resources we have so that you can take this back to your students. So we're going to be doing this activity today, and then feel free to join us for our next session, which is a more intermediate level activity. So we've got the link in the chat, rpf.io/dm-stress-ball. So I'm going to go ahead and open up that so you see where that link goes to. So, I think I need to make mine a little bit bigger. There we go. All right, so you should see it. Great. So this is one of the projects on our project page, projects.raspberrypi.org. And so at the foundation, we have tons of free resources ranging from materials and training, I'll talk more about those later, to these projects. And I absolutely love these. These are step-by-step projects for a young person, a teacher, a class to go through a coding project together. So we're going to be going through this project where we're going to be creating a stress ball with Scratch. And this is a great beginner project. You'll learn about sprites. You'll learn about how to just use Scratch and how to add a background and how to add in sort of an interactive aspect of Scratch, which would be really fun for kids to share with their friends and family. So what we're going to do is, well, actually, I'll show you sort of how I move through to start. You've got this link. I understand that you probably have me up, you've got this link up, and then we're going to actually open up a Scratch window. Feel free to, you can just open up whatever works for you. And if you like, I think these are also being recorded, so don't feel like you have to code right now. Follow along just so you get the resources you need so that you can run a fun activity for your kids. So what we're going to do, we see here the introduction. It always gives us like an overview of the project, like a preview. We're going to jump in to the first step, which is we need to open up Scratch. So I'm going to go ahead and open up Scratch in a new tab. And this is going to take us to a different website, scratch.mit.edu. And this is where we're going to be coding. And like I said, I love Scratch. It's a great beginner-friendly project and program. And it's also great for like kids, especially if they're new to using computers or their hands aren't big enough to type yet. It's a lot of drag and drop. All right. So I just wanted to check in on the chat, make sure we're doing well. Great. Okay. So follow along with me or open up Scratch and I'll do a quick introduction to Scratch and then we're going to jump into our coding project. So Scratch here, what we see, oops, excuse me, I'm going to move this over. And that, what I'm actually doing is I'm moving Scratch and it's going to start blocking the chat and you. So if you can just flag me if there's anything I need to know that's happening in the chat. Sound good?
Sounds good.
Okay, great. Thanks. All right. So here we have Scratch. Like I mentioned, it's a block-based coding language. So here we have those blocks. And what we're going to be doing is we'll be moving them over into this coding space where we'll then see our code come to life on the stage, which is here. So for example, we'll start off by grabbing a starter block. When the green flag is clicked, we're going to grab looks. We're going to say hello. I remember Yvonne's name, so I'll put that in here. And I'm going to go ahead and run this program. This is my first Scratch program. We just got the cat to say hello. And that's kind of the basics of what Scratch is. This here is a sprite. So a sprite is a character, an image that we're going to be coding to do something. Then we can also add in backdrops. And we have Scratch blocks from motion, looks, sound. And I love that Scratch is organized both by like categories, but also by color, which can be really helpful for kids as they're getting started. So I'm going to move this code and we're going to jump into actually making that stress ball. So first thing we're going to do is we're going to make a sprite, which is really neat. In Scratch, you can either choose a sprite from a library or you can also make one. We're actually going to do both. We're going to choose a sprite. So I just clicked on that bottom right, the cat icon, and it opened up a library of sprites. And here you can search, actually see the one I want, but I'm going to go ahead and show you. I'm going to search for the ball and pull that one up. All right. So with this project, I want to make kind of like a funny stress ball for kids. And this is a great project because kids can personalize it. they can be really creative with it, add colors, add an image, add a face. So I want to actually make this a little bit bigger, which I can do here in the bottom sort of sprite section. I'm going to change the size to 400. All right, there we go. Great. Okay. Now with Scratch, if I ever want to modify or change a sprite, I can go to costumes. And here's where a lot of fun is with this project, is really personalizing your stress ball. And this is a project we've done a couple times with some live coding sessions. My colleague just did it yesterday with a group of like 200 students for a coding club, and they had a lot of fun with it. And the kids shared out the different stress balls that they made. So here I'm going to add a face. So I can do that. This is, for those of you who've used like Paint before, it's a really similar layout. I'm gonna grab a circle. I'm gonna go ahead and put that. Oop, there we go. Nice. Oh, that looks fun. So I'm gonna go ahead and add in a face here. Let me see, I'm gonna change the outline. I'm gonna have it just be like one color. And lots of like personalization, like I said, which is what I really like about like this project. Let's see, well, let's keep it this black too. Yeah, and then, oh, it's not clicking. Oh, I have to select, ha, okay. Click on select, here we go. I'll make this all one color. All right. And then fill it in. All right, let's go ahead and add a mouth. And what I've seen kids is go pretty wild, like with hair, with different like characteristics. You can also change like which of these, like with a sprite in Scratch, some of them have different costumes, which can be really entertaining. We see here, we have different colors. So you can personalize your sprite that way. What you'll see though, is that I edited this first costume. So those edits didn't reflect into the rest of the costumes. So let's just, well, actually, you know what? Actually, yeah, we're going to keep this just as their face so we can jump into like the coding piece. All right. Any questions so far? Just want to open it up to questions from the group. If not, I'm going to keep on going.
You're good to truck on. Just excitement for PyCademy.
Lots of love for PyCademy. I appreciate that so much. All right. So with this, and like when I do these projects with kids, either I might share the stress ball link that I showed you all earlier, or I might have it up and code along with them and just show them the steps that I'm doing in Scratch. So I'll actually show that right here. In the project, you have like your different steps. So we started off with the add the ball sprite. And what we're doing now is we added a face. Now we're going to put in the code for squashing, shrinking, and adding some sound. So earlier I had used the block for when the green flag was clicked. Let's go ahead to events. What I'm actually going to do is I'm going to use a different one for when the sprite is clicked. Because I'm thinking here, I want to create a project, and a lot of times will try and be meta with kids when I'm telling them what I'm creating. In this case, I want to create a project that when I click it, something will happen. It'll sort of twist and turn and make a funny face. So when the sprite is clicked, we are going to have it squash it. And so to squash it, that's going to go to looks. And if you're new to Scratch, one of the most important things is to note is that a lot of times you'll see like a down arrow that gives you a lot of really great options. So for example, here, this block says change color. We actually have a lot of other options that we can pull from. So we're actually going to use the whirl. What I want to do is I want to use the set one. Here we go. All right, so let's test this out. When I click my sprite, oops, it's on 0. We don't want it to be 0. We want it to be 100. All right, yes, okay. First step is done. All right, next thing I want to do is I actually want my my stress ball to get a little bit smaller. So I'm going to use the change size block. So I'm going to grab this one here. I'm actually going to put it above, and I'm going to have it change size by -50. All right. Okay, great. So we're seeing that like sort of shrinkage happening. So we're starting to have more of a like interactive experience with our stress ball. So next thing I want to do is I want it to return back to the state that it was. So there's a great block for that, clear graphic effects. So now when I click it, ooh, okay. So we're seeing kind of a delay. So we're wanting that to actually be more of like how do we best explain this? All of this is happening right now in our code. It's just happening so fast that we're not getting to see the change. So we need to add in it's a little bit more. Let me move here. And what I want to do is we're going to add in a wait. All right, here we go. Probably wait 2 seconds and see if that works. All right. Great. Okay. So now we're starting to see how this code is working. This is why this is a great project for newbies, for kids who are they're seeing like, oh, okay, I have to really have to tell the computer every single thing that it needs to do. But as we're noticing, or you may have noticed, every time I click it, my my stress ball is getting smaller and smaller. So I want to add in that extra block there to also make it that my graphic effects are going to clear, but my stress ball will go back to the size that it was. So maybe you might be coding along, you might have a guess of which one it is. It's going to be in looks. And we're going to go back to, here we go, set size. So my original size was 400, and that's where I want it to start. Let's go ahead here. And then, there we go. Okay. Now, one of my favorite parts of this is with this project, we also get to add in sound. So I'm going to go here. And so far what you've seen, we have used the blocks. We've added in a sprite. We've changed the looks. So this project's a lot about using the looks blocks. And we are now going to add in some sound. So to add in sound, similar to sprites, there's a whole sound library. So depending on if you're back in the classroom and doing this project, you may want to have some headphones. I'm just gonna, this is your first time using Scratch, have some headphones for kids to use, or give them a warning that they're going to be hearing the sounds. So let's go ahead and pick a sound. I'm going to pick this one. And let's see, I'm going to add in a sound. So to do that, I need to scroll down here. Oh, wait, I'm going to go up here. And then I'm going to add in, I'm going to choose in a sound here, and I'm going to add in, there's a fun squeaky toy sound, which goes really well with this project. And like you see, there's a lot. So imagine what a kid can do with Scratch we have a project for a rock band. We have a project from like flying through space. So I'm going to pull up the squeaky toy. Yep, that's the one I want. I'm curious. I wonder if you might be able to hear it when I play it. Did you hear that? Okay, I saw that nod. Okay, great. All right, so that's the kind of like added to like my library now. So I should be able to pull it from here. Great, now it's been added into this block. And so I can add it to here, and let's see how it's going. Yes, okay. The relief, the stress relief that I'm feeling right now. So this is our beginner project. And that was just sort of the base of what you can do with this project. You can have kids, encourage them to think about other effects, right, that they can add. What could they do with the sound? Maybe they don't want to use the whirl, but they want to use the mosaic or brightness. There's a lot of really fun effects that you can use in Scratch, thinking about sounds. And we also put these suggestions so that you're not having to come up with those add-ons or those challenges. If we go back to the stress ball project, let me pull that up here. We have here challenge, improve your stress ball. So let's open that up. And it'll talk about like using the brush tool, add some hair or other features. There's a lot of guidance in here for teachers and for the kids, which I really appreciate. And our content team has gotten fancy. They have like GIFs and videos that they have in the projects now. And then additional challenges here for improving your project. One thing I just saw is we need to add a backdrop. I want to make sure to show you how to do that before we leave the Scratch session. So let's pull that back up. Oh no, Scratch, where'd you go? Oh, there it is. Okay, great. So we've added a sprite, we added sound. Another really great thing with Scratch is you can add backdrops, which really makes it come alive for a kid. We can put this stress ball in many different scenarios. So let's actually check those out. All right. So similarly, we have a library. We have some categories at the top that kids can explore. So you see, we could be in the Arctic to a bedroom to a canyon. I am partial towards space. So let's see what we find here. Ooh, lots of really great ones. So I think I'm going to go with a nebula. I think I want my stress ball in a nebula. Look, that looks so awesome, right? So just added in the backdrop. Now, two great things. Oh, I'm seeing this is making it smaller for y'all, so I'm going to make this a little bigger. So what I just did was I added what was already in the library. You may have seen when I was clicking on sounds, you also see here, you can upload sprites. You can upload backdrops, which can be like that is the sort of the next level. I've done sprite projects where I have me and my colleague flying through space, which is always really fun. And this is just the beginning of what you can do. I've seen kids who have made games where multi-level games that you are traveling through, like kind of like Mario-esque, like you're traveling through another world, which can be really, really fun. So just to wrap up and check out the stress ball project. So like I said, we've got challenges, we've got recommendations for what's next. This one, which I love, is it says we're currently like on the Look After Yourself projects, and they'll give a recommendation for the butterfly garden. And we love to like guide folks and help them know, okay, you did this project, the stress ball project. Here's what we recommend is next to keep you building on those skills, which is a really powerful and really important part of digital literacy. So with that, I'm going to come back here to our slides. All right. So, well, actually, I mean, before I leave, leave this Scratch, I want to talk about some resources we have. But before I do leave Scratch, I just want to ask if there's any questions about that project, what we just did in the Scratch project, how to use Scratch in your classroom. Just open that up. What's really neat about Scratch is I just did that. I didn't have to log in. So that's a great thing if logins are a concern. However, though, if I want to save my project, I would need to sign in and save this project. You can also create like Scratch classrooms as a teacher with your students. I encourage you to explore that if that's something that you are interested in. And so with that, I'm not seeing any questions. I'm going to hop back in because I want to tell you about some additional resources as you're creating your plan for both CS Ed Week and also just like collecting resources for CS.
A question just came up from Yvonne here about.
Oh yeah, of course. Go ahead.
Yeah, asking why would I pull out Pis if I have PCs for this project? Great question. You don't need a Raspberry Pi to follow our resources. That's the short answer. A lot of our resources are made for whatever technology you have. Of course, we love the Raspberry Pi because it's an affordable computing device that we provide. But yeah, I mean, we just want young kids learning how to code, and so we provide lots of projects and resources that don't necessarily require that hardware.
Yeah, right. So, I mean, if you have PCs, you can do this on your project. If you have Raspberry Pis, you have Scratch uploaded on there, you can do it there. And I think it's an important thing. The work we do at the foundation is device neutral. So I do a lot of work to show folks just how to get started with coding. Our next session is going to talk about the Raspberry Pi, but we're actually going to do like a virtual exploration of using the Sense hat on the Raspberry Pi, which I'm really excited about. Yeah. Did you want to add something, Matt? Or?
No, I was going to say just that same thing is that the next session does have a Pi element to it, but it also has a simulation of the Pi, which is cool.
Yes. Yeah. We want to make sure everyone can participate. So yeah. All right, great. So moving back here, I just want to show you all a couple of resources. So like I mentioned, that mission of putting digital making into the hands of people all over the world, that looks like this: resources, projects for folks to explore coding. It also looks like a couple of other programs we have. One is Digital Making at Home, which is our weekly live stream. Every Wednesday, myself, Matt, and a couple of our colleagues, we do some live coding. We also just interview and chat with some really awesome folks. This is from a couple weeks ago where we coded actually with Yolanda's former student, I believe, Jordan, and got to hang out, and that was a lot of fun. And to Today we interviewed Randy, who is a PhD candidate at MIT, and talked about machine learning. We've talked with folks from Ecosia, which is a really neat search engine. We did a theme around like digital, like technology for good. So we definitely encourage you all to check out all of our past session, or all of our past streams are on the link at rpf.io/home.
I'm holding this up for Brian. There's the Pi 400. This is our newest Raspberry Pi in a computer.
Yes, yes, very
in a keyboard.
This came out last week, right, Matt?
Yeah, yeah. It's really neat. It's kind of like the old, the old school computers and a keyboard, ZX, a Spectrum, BBC Micro, but this is much more powerful.
Yes, yes, yeah. Yvonne, I want that. Yeah, me too, Yvonne. Matt was special. He got it early so he could test it out.
It's cool. It's cool because you just plug in a TV or monitor, mouse, and power, boots right up, and that's a full desktop computer. And for learning in particular, it's great. It still has the pins on it, the GPIO pins on it, so that if you do physical computing, it's going to be a little hard to use it. I suspect we'll see more products that'll kind of like break those pins out and put so that you can do physical computing like on a breadboard. Advanced stuff, but still it's a possibility with this. It's neat.
Yeah, awesome. Thanks for sharing about that, Matt. So yes, Raspberry Pi is another one for sure. Another resource that you can check out. And the Raspberry Pi 400 new just came out last week. We have digital making at home, and we also, like I mentioned, the projects. So if you go to rpf.io/projects, you can check out over like 200 more projects. The stress hat or stress ball was just the beginning. We have projects from tons of different languages. We also have projects for the Raspberry Pi. So if you have a set of Raspberry Pi, a set of Raspberry Pis in your classroom, I encourage you to check out those projects. A lot of really great like intro projects, as well as like for this one, this is like how to build like a cool robot, getting started with the GPIO pins. Then I also highly recommend our online courses. These are free self-paced courses from getting started with the Raspberry Pi, physical computing, to just like programming 101. So an introduction to Python, to one that I love is moving from scratch to Python. So if you're coding with your students and you want to think about how can I have them go from block-based to text-based, that's a really great course. And there's lots of courses. We're adding new ones. Like almost like really pretty regularly. So I encourage you to check those out. They are free. If you want there's like a cost if you wanted like a certificate, but they are free and open for you to use. And thank you, Matt. Matt's putting all of these links into the chat.
And these courses are designed for educators. They're educator professional development. So they're designed with pedagogy in mind, how to teach. Although we do know a lot of people who use our courses who are not educators as well, because it's all totally free. So yeah, there's tons of great topics. Again, not just about Raspberry Pi hardware, but all elements of computer science education.
Yeah, thanks, Matt. Appreciate it. All right. So I want to open it up again for questions, and we're open like to questions that we'll answer them now if we can, or we'll definitely take them back and try and find you an answer, ranging from a Raspberry Pi to Scratch to any of the resources I just mentioned. And while y'all are typing those questions, I'm going to close this window. This is one of the first I presented, yeah. And it's sunset is happening right now. Here we go. I can see. But yeah, if you have questions about the Raspberry Pi, about any of the resources we just talked about, Matt and I are your folks to help answer those for sure. So I'll give you all some time there. Move this around. Oh, great. We're doing great on time too. I was like, I'm not going over.
Yeah. Coolest projects. That's a great idea.
Oh, that's definitely great. Thanks for, yes. So Yolanda is a big fan of Coolest Projects. She has come out to California. Seeing some other questions, great. So Coolest Projects is our showcase for young people to come and share what they've made with code. And that has in the past looked like an in-person event where it's basically like a science fair for coding. It's so much fun. Kids come in with some incredible projects. And this past summer, we did it virtually, and it was amazing. We had kids sending in videos, sharing what they were making from all over the world. So stay tuned. There's more information. You can look up like coolestprojects.org and learn more. We'll be announcing hopefully in the next like month or two around what to look for Coolest Projects 2021. I'm seeing a question, little screens that you recommend using with the Pi. That's a really good question. Matt, do you have a recommendation?
Yeah, so there are, if you go to Amazon, honestly, there's a bunch of screens, and you can just search like Raspberry Pi HDMI screens, and there's a nice selection. The one I like is called it's got a weird brand name. It's called Sunfounder. And they've taken a screen, an HDMI screen. It's just a regular HDMI screen, but they've kind of built a case that's just for Raspberry Pi. And so I've had mine for quite a few years, and it's worked really, really well for a kind of a small desktop screen that works just really, really well. It stays out of the way. I also just recommend that for Raspberry Pi hardware is that we do a lot of events, and we buy screens. There's always like a very affordable option of like around $60 for a small HDMI monitor. It's nothing fancy, but it does work. They tend to work pretty well, and for $60 you can't really beat it. Maybe $75 at most. But those. And I suspect over time we'll see those perhaps come down in price too. But we find that those are great. If you want something more reliable, HP makes a $90 monitor that's a little bit more robust. It's a little bit more what you might find in a work environment or in a school environment. And those we found for cases where we want a more reliable monitor solution, there's very, very affordable monitor options at all different levels.
All right. Thanks, Matt. Hope that answered your question, Brian. Feel free to let us know if it didn't. And Yvonne asking how to follow us on Twitter. Matt just put in our link at Raspberry Pi. You'll probably also see us get retweeted sometimes by Raspberry Pi. I'm Foustberry Pi. Matt's Matt Richardson. Feel free to follow us for all the fun things we're doing. A lot of times it's code. Sometimes in the future, it's going to be about my puppy. I'm getting a dog. That's on my Twitter, but definitely follow Raspberry Pi for updates on both the computer and the resources that we're making.
And Yolanda's saying to get those monitors on Amazon with donors choose. That's great. That's great. And there's a question about Arduino and Raspberry Pi. They work well together. Since you need a computer to program an Arduino, Raspberry Pi can be that computer. And so you can download the Arduino IDE into the Raspberry Pi. And then when you have them talking to each other, you can do some pretty cool stuff, because the Raspberry Pi has capabilities like computer vision and camera work. And so you can kind of combine your Arduino and Raspberry Pi projects like that, because they both have different strengths.
Yeah, definitely. All right. I do want to be mindful of time. So thank you all so much for joining us. Like, we really appreciate it and loved engaging with all of you. So with that, follow us. Yeah, follow raspberrypi.org or check out raspberrypi.org. Follow us on Twitter. And we'll be doing another session during round 3. That one, we will be doing coding with Python on the Raspberry Pi, specifically with the Sense Hat. So if you're interested in that, feel free to join us for that one. We'd love to see you. All right. Thank you all so much.
Bye, everyone. Thank you.